Today's video is on applying function notation, and applying function notation is where we use our knowledge about function notation to solve different kinds of problems. So in this video, we're just going to go through a couple of examples showing how we can use our function notation to solve problems. So let's dive straight into an example. And the question is, if f with a domain of all real values with an equation f of x is equal to ax plus b, the question asks us to find the values of a and b and sketch the graph. And it gives us two pieces of information. F of 1 is equal to 7 and f of 5 is equal to 19. We can start off by creating our equation. So the equation we've been given is f of x is equal to ax plus b. If x is equal to 1, so if we use our information of f of 1, we know f of 1 is equal to a plus b, and since f of 1 is equal to 7, we know a plus b is equal to 7. And now we can do this with our second piece of information as well. So we can write f of 5 is equal to 5a plus b, and if f of 5 is equal to 19, we can write 19 is equal to 5a plus b. And now we can label our equations. So we've got 7 equals a plus b is our first equation, and 19 is equal to 5a plus b is our second equation. Now we can do our second equation minus our first equation, and we get 19 minus 7 is 12, 5a minus a is equal to 4a, and b minus b is nothing, so we just get 12 is equal to 4a. And if we divide both sides by 4, we get a is equal to 3. But we need to find the values of a and b. And so to find the value of b, we'd sub 3 back into our equation. So we get 7 is equal to 3 plus b. And if we subtract b from both sides, we get 4 is equal to b. And we can now write our equation as f of x is equal to 3x plus 4. And we can see that this is the equation of a straight line. So we know that when we graph our function, we're going to be graphing a straight line. And now what we want to do is we want to find 2 points along the line so we can connect them up to create a straight line. So we'll just sub in two values of x. We'll say f of 1, so that's equal to 7 because we get 3 plus 4. And we actually already have that from f of 1 is equal to 7. And we can also do f of negative 1, which is negative 3 plus 4, which equals 1. So now we can draw up our graph, draw our axes, put our 2 points on there. We've got when x equals 1, y equals 7. And when x equals negative 1, y equals 1. We can connect the dots, and that's how we do that kind of example. Okay, so let's do this next question. And the question is asking us to write f of x equal to x squared minus 6x plus 16 in the form of f of x is equal to x minus 3 squared plus p. And it wants us to also state the range of f. So because it has a perfect square plus a number on the outside, we know that what we want to do to get there is complete the square. So if we take our equation and we'll write it down, f of x is equal to x squared minus 6x plus 16. Let's complete the square now. We know it's equal to x minus 3 squared. And negative 3 times negative 3 is positive 9. So if we create positive 9 in the x minus 3 squared, we need to subtract positive 9 and add 16. And so we get x minus 3 squared plus 7. And now it wants us to state the range of f. So because this value of x is being squared, we know that the lowest it can be is when our brackets is equal to 0. And when our brackets is equal to 0, y is equal to 7. So our lowest value of y is 7, and our highest value goes to infinity. So our range would be equal to square brackets 7, since 7 is included in our range, comma, infinity. So let's move on to our last example here. And we have the question, our function with the domain of all real values and an equation of f of x is equal to ax squared plus bx plus c. By looking at our equations, we can already see we have the general form of a parabola. So we're dealing with a parabola here. And the question asks us to find a, b, and c, and gives us 3 pieces of information. F of 0 is equal to 2, f of 4 is equal to 0, and f of 5 is equal to 0. And the question has given us 2 x-intercepts here, and we can use these x-intercepts to find our values. So we know that the x-intercepts form of our parabola is f of x is equal to k brackets x minus e and x minus f, where k is our dilation and e and f are our values in our x-intercepts. And the values of our x-intercept are 4, 0, given by the second piece of information the question gives us, and 5, 0, which is given by the third piece of information the question gives to us, because we can see when x equals 4, f of x, also known as y, is equal to 0, and when x equals 5, f of x is equal to 0. So those are our 2 turning points. So we can sub those values in. So f of x is equal to k brackets x minus 5 and x minus 4. And so now to get our value for k, we can sub in our other piece of information given to us, that when x equals 0, y is equal to 2. So we can write 2 is equal to k brackets -5, -4. And so 2 is equal to negative and a negative multiplied each other, which equals positive 20k. And if we divide both sides by 20, k is equal to 1 over 10. So that's our value for k, and we've now got our equation, so we can find our values for a, b, and c by expanding our equation. So if f of x is equal to 1 over 10, x minus 5, x minus 4. So we can expand our x minus 5 and our x minus 4. So we get 1 over 10 brackets x squared minus 9x plus 20, and therefore f of x is equal to 1 over 10 x squared minus 9 over 10 x plus 2. A is equal to 1 over 10, b is equal to negative 9 over 10, and c is equal to 2. Thanks for watching.